Now, the world's biggest lighting maker, Signify, tested its latest ultraviolet light technology with researchers at the Boston University and found that UV light exposure breaks down novel coronavirus particles in seconds. Signify country manager Jagan Srinivasan now joins us to tell us all about the science of this exciting development. Hi, Jagan, thanks for joining us.
Hi, Michelle. Great to be here.
Great, and great news from your end. I know that Signify, formerly Philips Lighting, has been developing UVC for over 30 years. You know this stuff well. So talk to us about the science of how UVC erodes or eradicates virus particles.
Yeah, that's correct, Michelle. We've been in the ultraviolet lighting business for 35 years, and we've been working on development, production, as well as applications. What ultraviolet lighting is all about, there are three kinds of it. It is something that comes naturally in sunlight, but what is known as ultraviolet C is blocked by the ozone layer. Now, where it's necessary, if you are able to produce ultraviolet C, it has the effect of destroying the DNA and the RNA of viruses, bacteria, fungus, molds, and spores, and so on. So that is basically what is being used here, the property of ultraviolet light C to deactivate the DNA and the RNA of the viruses. We have known that there is no known pathogens that can survive an appropriate dosage of ultraviolet radiation. However, it was untested and unproven on this specific virus that is causing the COVID-19, which is the SARS-CoV-2 virus. So what the test results that you were referring to at Boston University School of Medicine confirm is the effect that an appropriate dosage of ultraviolet radiation has on this specific strain of virus.
You guys tested this, as you mentioned, in a level 4 biosecurity lab at the Boston University. What were the findings? What, for example, what time exposure versus how much of the virus can be eradicated within that time exposure?
Yeah, so basically what we've been able to establish is at the right dosage level, 3 seconds of exposure killed 90% of the viruses. And then to find out, because 90% is simply not good enough, 6 seconds results in 99% inactivation of the viruses. And if you want to go for 99.9999%, it took us 25 seconds. So all of this is extremely interesting news for the situation we face today. And we are very excited because this gives us the opportunity to bring to the world, bring to the market, a preventive measure for all of us. I mean, whether it's companies, institutions that are looking to provide a virus-free environment, because that's basically the root cause where this pandemic continues its spread.
Jagan, interesting question. Do you think this can also clean the air? Does it clean the air as well?
So, Michelle, yes, there are ways of cleaning the air using ultraviolet, but of course it needs to be done in an appropriate way, specific to the environment. We have what is called upper air cleaning, whereby an ultraviolet light is cast upwards from a high-mounted light fixture, and in an air-conditioned space where there is a natural air convection happening, the cool air that is from the air condition at the top comes down and the hot air rises, and that circulation ensures that there is air that is moving all the time, and the air that is exposed to the ultraviolet radiation at the top is cleansed and disinfected.
Jagan, you mentioned this briefly earlier, but for the science geeks out there, the most natural UV light is generated by the sun. Now, of the UV radiation that reaches Earth, around 95% would be UVA, and only 5% is UVB. UVB, for those interested, would be responsible for your sunburn. It also causes skin cancer. UVA, on the other hand, is able to penetrate more deeply, playing a greater role in skin aging, wrinkles, can also be used in printing, lithography, and some medical applications. But UVC, you don't get or harness UVC from the sun, right?
Yes, that's correct. Thankfully, we have an ozone layer that blocks out UVC because, I mean, what UVC is doing in this case on the virus, it's capable of doing without making the distinction on which cells. So, in the natural world, the sun's UVC radiation is blocked off by the ozone layer. Now, in the kind of settings applications that we are talking about, we are producing UVC as a result of a chemical process within a light source, and that UVC radiation is harnessed where it's desired in order to have germicidal property.
And absent a vaccine, UVC technology is a preventive measure. We know that hospitals have been using UVC to disinfect or kill the superbugs. Where else do you see the application? Perhaps in restaurants or in clothing retail? Tell us more about the application.
Yeah, actually, if you think of it, the application areas are numerous. Think of it as any place that is exposed to frequent people movement, which runs the risk of having residual deposits of particulate nature stay on surfaces or in the air, is a likely candidate for disinfection via ultraviolet lighting. So to give some specific examples, public transportation is a segment. We've been having inquiries from airports, inquiries from railways, LRT, to disinfect train compartments in their depots and so on. We are having discussions and we have customers from retail segment, supermarket outlets where typically everybody uses a shopping trolley, and that's one of the things that's most often touched by every single person in the supermarket. Now, there is a kind of ultraviolet tunnels through which these push carts are pushed through, so that when they come out from there, they come out disinfected for fresh use by a new customer. Another example, if you go to a clothing outlet, for example, in a trial room where you try on clothes, the outlet owner is very interested in ensuring that that piece of clothing, garment that was tried, is disinfected. So we can have chambers into which you put this piece of clothing for a few seconds, and then it comes out ready to be tried by another person and disinfected before that.
Jagan, very quickly, will skin exposure be dangerous to humans?
Yes, ultraviolet exposure is not recommended for humans. So, like with most things, appropriate use will give us the results that we're looking for. And misuse or inappropriate use could lead to undesirable results. So what we do in all our ultraviolet propositions, we try to have instructional safeguards in the form of active communication on how to use it and so on, but that's the bare minimum. In addition to that, we have time safeguards or equipment safeguards or containment safeguards. So intelligent systems that can detect presence of humans or pets and switch off the entire system so that there's no accidental exposure.
And this UVC technology that you're using, is it new or specifically created for COVID-19, or is it the existing one that you've been manufacturing for years?
It is an existing one that's been manufactured for years, although the relevance and the urgency is very different right now because of the COVID situation. Historically, almost all water treatment plants will use some kind of a UV treatment in treating the water before it's considered drinkable. Historically, hospitals will have specific parts of the hospital which is always disinfected using ultraviolet. But now, I would say what used to be a niche business is obviously becoming much more of a mainstream business when it comes to ultraviolet lighting.
Jagan, we don't have much time. Very quickly, final question. What volumes, what production capacity are you looking at today? And do you plan to ramp that up to what level? I know that this could provide a new revenue stream for Signify because revenues were down 15% in Q1.
That's correct, Mimi. The COVID situation left none of us immune. But what we are literally able to say that we can deactivate the virus, we are also metaphorically able to say that there is new opportunities opening up. We will see business possibilities with this. As we speak, we are ramping up production multiple fold as compared to what it used to be. Our factories, most of our ultraviolet production takes place in Europe, and factories are ramping up production, and we are increasing capacity as we speak.
Okay, on that note, thank you very much, Jagan, and good luck. This is something that, this is good news for the world. Thank you for joining us this afternoon.